So, your card data already lives in VGS, and you want Hyperswitch to route payments across Stripe, Adyen, and Worldpay. Can Hyperswitch do that without ever touching the raw card number? The answer is yes, it can. And the way you wire it decides your PCI scope. The vault sits upstream of every PSP integration, not inside one. VGS holds the card, Hyperswitch holds a token, and the processor, Stripe or Adyen, just sees a normal authorization request. It has no idea a vault was ever in the path. There are two ways to wire it. In one, Hyperswitch pulls the card back from VGS and sends it to the PSP itself. In the other, it routes through the VGS proxy and never sees the card. That is the whole design, and everything else in this video is how the pieces fit together. Before we go deep on VGS, it helps to place it, because VGS is one of three ways Hyperswitch handles a raw card number. First, the built-in card vault. That is Hyperswitch's own card vault, the Hyperswitch Card Vault service. It is PCI and GDPR compliant, and it is the default for most merchants. It gets its own deep dive, so we will keep it brief here. Second is the external vault route. This is, bring your own vault, you point Hyperswitch at a provider you already use, and nothing gets retokenized or migrated. Today, you can use VGS or TokenEx, and we will walk through VGS. Third is guest checkout, the transient path. Here, the customer is not logged in and is not saving a card. They just want to pay once. Hyperswitch holds the raw card only, for as long as that one transaction needs it, in memory, and nothing is written to the persistent database. Once the payment is done, the card details expire. So this one is not really a place a card lives. It is used for the moment, then it is gone. So the real choice is between the first two, and it comes down to where the card sits at rest. Today, we are going to talk about the external path with VGS as an example. Let's start with where the vault sits. In a payment orchestration stack, the vault sits outside the PSP integration, not inside it. The vault holds the card number and hands the caller back a token. The caller, your server or Hyperswitch, holds that token and sends the PSP a payment request. Storing the card and routing the payment are two different jobs, and keeping them on opposite sides of a clean boundary is what decouples the vault from the processor, so you are not locked to one PSP. So why configure Hyperswitch to use VGS instead of its built-in vault? Usually one of three reasons. Your cards already live in VGS from an earlier integration, or a compliance decision. Or you want one vendor for orchestration and a different one for storage. Or you want to switch without migrating stored cards. Either way, you do not migrate anything. You connect the vaults you already have, and from then on, the token, not the card, is what Hyperswitch keeps against the customer. How much the orchestrator touches the card at payment time is what changes between the two shapes, vault as storage and vault as experience and storage. For a self-hosting merchant, that is the lever that decides your PCI DSS scope. There are two ways to wire VGS behind Hyperswitch, and both have names, Vault as Storage and Vault as Experience and Storage. Before we split them, here is what they share. In both, VGS stores the card and hands back a token, and Hyperswitch keeps that token against a payment method ID, the stable handle for the customer's saved card. When a card is saved, that store step is the external vault insert. When the saved card is charged, pulling the token back is the external vault retrieve. Where the two flows split is two moments. Who first touches the card when it is saved, that is capture, and who holds it when the saved card is charged, that is payment. Take them in order. Capture first, the first time a customer saves a card. In Vault as Storage, Hyperswitch's own checkout collects the card, so the card lands on the Hyperswitch server first, and then Hyperswitch sends it to VGS to store. In Vault as Experience and Storage, Hyperswitch's SDK embeds the VGS SDK using VGS Collect, so the card goes straight into VGS and Hyperswitch only gets the token back. Same end state, a token held against a payment method ID, but one flow passed the card through Hyperswitch and the other never did. Now payment, when the customer comes back and the saved card is charged. In Vault as storage, Hyperswitch resolves the payment method ID to the VGS token, calls VGS to detokenize, gets the raw card back, and sends it to the PSP itself, straight to Stripe or Adyen. There is no proxy in this flow. In Vault as experience and storage, Hyperswitch builds the PSP request with the token and sends it through VGS's outbound forward proxy, which detokenizes the token into the real card on the way to the PSP. Same split as capture, the card passes through Hyperswitch in the first flow and never touches it in the second. So one line decides everything. Does Hyperswitch, the orchestrator, ever touch the card? In Vault as storage, yes, when the card is saved and again when it is charged, which keeps PCI scope on Hyperswitch. In Vault as experience and storage, no, which is what lets a self-hosted Hyperswitch stay out of PCI scope. A SaaS merchant may not care. A self-hosting merchant usually cares a lot. Let's wire up the storage flow, the one we can run end-to-end today. Under the Connectors tab, you'll see the Vault Processor sub-tab. When you click on it, you'll see the VGS connector. Let's connect it. You give it 3 credentials: your VGS client ID, your VGS client secret, and your Vault ID. These values come from VGS itself when you create an account. The next thing you need to do is enable it on your profile. Under the Developers tab, click on Payment Settings, and go to the Vault tab, the one sitting between 3DS and Custom Headers. Flip on Enable External Vault, pick your VGS connector in the Vault Connectors dropdown, and hit Update. That is the whole enablement, a toggle and a connector choice. One thing to call out, the Vault is storage. It does not sit in your payment routing, so leave your routing as it is, Stripe on top or wherever you want it, and the Vault just handles where the card lives. Here's how my payments are routed with Stripe being first. Now, let's run a payment and save the card. Saving a card during a transaction with the customer's acceptance is what triggers the external Vault insert. Hyperswitch stores the card with VGS, gets back a VGS token, and creates a payment method ID with that token held in the payment method entry against the customer. That payment method ID is the stable handle you reuse on every later payment. Let's repeat a payment for $50 for a new purchase. The customer comes back, picks the saved card, enters the CVC, and pays through Stripe. At this point, Hyperswitch only has the VGS token, so it calls VGS to detokenize, gets the raw card back, and sends it to Stripe. That round trip is the external Vault retrieve. It is also the moment Hyperswitch holds the card, which is why this flow keeps PCI on Hyperswitch. Here is the boundary, stated plainly. VGS owns the card storage, and in the proxy flow, the outbound proxy that swaps the token for the card before the PSP. Hyperswitch owns the routing decision, which PSP, which capture method, which retry logic, the payment method ID that ties a customer to their stored card, and every orchestration flow once the token resolves. What crosses between them is the VGS token. In the storage flow, the card crosses too on detokenize, on its way to the PSP. VGS never makes the routing decision. The proxy flow runs this same idea without Hyperswitch touching the card. Here is the whole thing in one picture. One stable payment method ID ties capture to payment. It is created at capture when the card is saved and VGS hands back a token. It is resolved at payment when the saved card is charged and Hyperswitch gets the card to the PSP. VGS stores the card. Hyperswitch routes to any PSP, Stripe, Adyen, Worldpay, and the one thing that changes between the two flows, whether the card passes through Hyperswitch, is what sets your PCI scope. One last thing, because it is what makes all of this portable. That payment method ID is Vault agnostic. Hyperswitch can run more than one Vault at once, say VGS for cards you migrated from an older setup, and the built-in Vault for new captures, and resolve each payment method ID to the right one. That is what makes a migration painless. You connect the vaults and keep serving existing customers without collecting their cards again. And if you later switch PSPs, the payment method ID does not change. Hyperswitch resolves it and gets the card to the new processor. Thanks for watching. The full docs are at docs.hyperswitch.io, and the architecture write-up is linked in the description. If this was useful, like and subscribe for more.